finally, we get the power of .NET 9, and as you know,
with great power comes great responsibility.
I am currently playing Spider-Man, so... But what actually changes in .NET 9? Let's find out by building a complete web API with all CRUD operations. We're going to use the HTTP request methods get, post, put, and delete, and we store everything in a database. And for that, we use Entity Framework and Code First migrations. But first, let's celebrate the release of .NET 9 by hitting the like button. And to celebrate, you can now get a huge discount on the .NET Web Academy. In there, we dive really deep into all things .NET Web development and Blazor. So make sure to use the link in the video description below to grab your discount. All right, now the very first step, of course, if you haven't already, is to download the new .NET 9 SDK and also Visual Studio. So if you're brand new to that stuff, then please just Google for .NET download, for instance, and then you see the first hit usually is this page here. So just go to .NET 9, either use this link here, this button, download the .NET SDK. In my case, it is already recognizing that I need the 64-bit version for Windows, but otherwise you can also go to all .NET 9 downloads and then choose the right version for your system. So please download and install this thing. And then also Visual Studio, there is a community edition, which is totally free. So just go there, community, free download, and you are good to go. And this is everything you need for that. And when you've done that, then you can just open Visual Studio. And as you can see here, you should see this screen. We want to create a new project. And I already have it in my recent project templates here. What we want to do is building an ASP.NET Core Web API. But of course, you can also look for Web API here. And then you should hopefully find, when you scroll a bit further down, the ASP.NET Core Web API template. So do it as you like. We hit next. For this example, I love video games. I think you know that. Then we want to build a video game API, let's say. So this is our project name, Video Game API. In my case, location is development. The development folder solution name is the same. And I really try to keep things simple here for our beginners, but maybe also for intermediate developers, so that everything works for everyone. As you can see now, we've got the framework, the target framework. And as you can see, .NET 8 has long-term support, which is interesting because the support runs out for .NET 9 before the support for .NET 8 ends. But still, .NET 9 is the latest version. So in our case, we want to choose .NET 9. Regarding authentication, we won't use any authentication type today. We do that in other videos. So let's now leave that at none. You configure everything for HTTPS. This is great. No container support, so we're not playing around with Docker or anything. But then comes something interesting, and here it says enable OpenAPI support. And this is a big change in .NET 9. As you can see here in the tooltip, it says enables OpenAPI or Swagger support. This is not totally correct anymore. There is actually no Swagger anymore in .NET 9, but I will explain the details in a couple of minutes. Then regarding the other checkboxes, no top-level statements. I want to use controllers, so in this case, this is no minimal API we're going to build. I can, of course, create another video for that if you want. Hit the like button and tell me that in the comments, please. Thank you. But now the usual old school controllers, I really like them, so I want to use them, and I think it's easier to learn with them. And .NET Aspire, we won't use this thing today. So let's hit create, and we get our example solution for now. And there we are. And again, to keep things simple, I don't want to dive deep into every details here. This is our solution, and you can see we got a bunch of files already. It's not that much actually, which is really nice in my opinion. Even if you have a closer look here, the weather forecast class and also the controller, which provides our endpoints, these are example implementations, right? And we're going to test them. But apart from that, the only thing we really have here is our Program.cs, and the Program.cs got a little bit smaller with .NET 9. If you are already familiar with .NET 8, maybe you already know that we got Swagger out of the box. And so what is Swagger? Swagger delivers a UI where you can test your web API endpoints out of the box directly. You run your application and you can test everything, which was great. But it is, according to Microsoft, and when you have a look at the GitHub repository, it is not really maintained anymore by its owner, so Microsoft changed something. But first, let's have a look at the other files we got here. Interesting is also see the appsettings.json here, where you can store, well, all the settings. For instance, later when we add our database, then we also can store our connection string to that database in the appsettings.json file. Another important thing is the launch settings.json, and as you can see here, we got some URLs already, localhost and then a port. And this is how we access our API so far. And the other thing, again, weather forecast controller are example implementations that we're gonna have a look at in a sec. And the last thing, let's say, to talk about here is this newish HTTP file. Now, what's that? Well, as you can see here, you can already test your API also with this file here. You can write your endpoints you want to test here and then run this thing. For instance, we can already say, I want to send this request for the example weather forecast. Then it is doing its magic and, for instance, says no connection could be made because the target machine actively refused it. Well, why is that? Maybe we should run our application. So we hit the play button there. All right, it is open. We can see that now here with the opened terminal, for instance. And now we send the request again. And as you can see, now it works. Let me hide the Solution Explorer here. And we see already the result. So let's have a look at the weather forecast example real quick so we understand what's actually going on here. First, the class. Here, it's pretty simple. We got a date, then a temperature in Celsius, and then also in Fahrenheit. And we got a summary. Now, what's that summary? Well, you see that in the controller. Here the summaries are freezing, bracing, chilly, cool, and so on. And what we got here is the controller for our web API. So this controller now provides all the endpoints, meaning we want to get the weather forecasts, we want to read them. So in essence, we say, hey, dear web API, dear web server, please give me some weather forecast data. And this is exactly what's happening here, but it's random data, right? So here, as you can see, Microsoft just implemented 5 random weather forecast entries, let's say, with a date from today on, and then random temperatures in Celsius. Then it is converted in Fahrenheit, thanks to the model. And then we also get random summaries. And this is our result. And regarding the URL, what you see here is we got 2 attributes. Here it says this is an API controller. So it says here indicates that a type and all derived types are used to serve HTTP API responses. So again, if you want to build a web API with old school controllers, then you need this attribute here because this then provides your endpoints that you can access then. And we got the route, which is also really important because this is how you well access your controller in the end. And this controller term here in these brackets, this is a convention, and this means that's the name of our controller. And the name is everything you find in front of the controller term. So in our case, it's the weather forecast controller. So weather forecast is the routes. And the last thing then is this thing here. Microsoft gave this thing a name, but this is not really necessary. Important is this thing. This is the HTTP request method. In our case, again, I will explain more or say more about the request methods later, but here this is a get method. All right, so whenever you want to test this thing, you also have to specify the request method. So how do you access this thing? We have others like post, for instance. This is another HTTP request method. So if you would say then in our HTTP file, or you want to try the get HTTP request methods, but in our controller, it's actually post, then this would not work. All right, so make sure to give these things the right name. By the way, there's also a convention. So for instance, if you name your method something with a get and you leave out this attribute, it still works because, well, .NET thinks, okay, this function is called get something, then this must be a get method. So we want to use the HTTP get request method, but it is really a better practice to name or to give all your endpoints the proper attributes with the proper HTTP request methods, in particular for the documentation that we want to generate automatically. this is way, way better then. All right, so this is the example implementation, and you can use the HTTP file here. But there is a much better way to test your API, and let me show you now what is actually going on with Swagger and OpenAPI. All right, so for that, let's go back to the launch settings.json file, and let me copy this URL here. So we got HTTPS localhost and then the port 7141. This is always different, so in your case this is, I think, definitely another port. And then open up Chrome. Now what we can do here in Chrome is we just paste the URL, and then again, since we want to access the weather forecast controller, we have a look again here in our HTTP file, for instance. It's pretty much the same thing. We got the host address and then weather forecast for our controller name. So weather forecast it is. And again, we get the data. We can format this thing so it looks a bit better. And we can also open the console. In my case, I just press Ctrl, Shift, and I, for instance. And then let me go to the Network tab. And here now, I just refresh the page. And here now, I also see the data. So this is also another way to test that, but again, this is only a get method. So how can we improve this? And this is where Swagger or another option comes into play. So let's check out something else now, and that's that. We see here in the documentation ASP.NET Core Web API documentation with Swagger / OpenAPI. There's a really important point I want to show you here, and it says the Swagger project was donated to the OpenAPI initiative in 2015 and has since been referred to as OpenAPI. Now this is important. Both names are used interchangeably. However, OpenAPI refers to the specification. Swagger refers to the family of open source and commercial products from Smart Bear that work and so on with the OpenAPI specification. So now you really have to differentiate this, because here it's an older announcement, but now that the 9 is here, it says Swashbuckle ASP.NET Core is being removed in .NET 9. Now, Swashbuckle ASP.NET Core is the package of Swagger. And why is it removed? It says here, Swashbuckle is a great project and we appreciate the time and so on. The project is no longer actively maintained by its community owner. Issues have not been addressed or resolved, and there is not an official release for .NET 8. And the same for .NET 9. So this is the reason why Microsoft removed Swagger now by default, but we have the OpenAPI specification. How do we get this thing? This is really important. Maybe you should write this down, because as far as I know, it's not documented inside the example project. You don't find a comment with the link, but what you can do is you can go to OpenAPI / then v1 for version 1 and then JSON. And I know this is a really, really long intro for the web API before we actually implement all that, but this is really important knowledge that you need when you want to build web APIs in the future with .NET 9 and above. So now here you have your specification file, right? This means whatever you're doing, whatever you built with a web API, how many endpoints you got, how many controllers you got, doesn't really matter. This is automatically specified in this OpenAPI file. As you can see, we got the weather forecast path, then an operation ID called getWeatherForecast, all right, and then some comments. This is our schema, our model in the end, the weather forecast model, and we got a tag down here, all right. So with this now, with this configuration, you can in essence use any tool you like. You can use Postman, you can use Insomnia, you can also add the Swagger package back, or use something new. And currently in the community, the best choice seems to be Scalar. And this is what I want to show you as well. So just remember, we have this configuration here. We can download this thing and use it in any tool we like, or we add our new package from Scalar and use this thing out of the box. So let's just do that. In the Solution Explorer, we right-click our project, manage NuGet packages. We go to Browse, of course, not installed, Browse, and then we just enter Scalar. There it is already. And as you can see, this thing has not been installed a lot. 55,000. Well, it is still a lot, but Swagger is in the millions. And here it also says generate beautiful interactive API documentation from OpenAPI / Swagger documents. As you can see here, they also added the term Swagger because it's still used interchangeably, but in the end, it's really OpenAPI. So let's just install this thing. All right, and when this is done, we just go to our Program.cs, and now it's really, really simple. just here in app environment is development. You can do it here. You can also use it in production, of course. So here in is development just means when you currently locally develop here and use the debug version, not the release version, then here we can simply add app and then map Scalar. Let me just write this properly. Scalar API reference. All right, this is everything. With control and period, we add the using directive or the reference. And now, as you can see, maps the Scalar API reference endpoint. All right, so now let me just restart the application again. When this is done, we go back here. And now the route that we want is Scalar and then v1 for version 1. And this is now our documentation. As you can see, we have our models, the weather forecast, for instance, and also the weather forecast controller. We can go to test request, then something else opens up, a modal dialog. We can add authentication here, for instance, cookies, headers, whatnot, and just hit send. And also we get our response status code 200 OK, and then also the body, so the actual results. Again, also headers, cookies, and so on, how long it took, and so on. So lots of great stuff. And now we can finally start implementing the controller, because there not a lot has changed actually, but this is the most important part really regarding the OpenAPI documentation. All right, now let's focus on our video game API. First step would be the model. So add root. Let me just add a new item. This would be the video game, and in here let's just add some properties like the ID, for instance. Then I just enter prop and then hit tab, so I get the property automatically. We add a nullable title, and then also the platform, the developer, and the publisher. Just an example implementation, right? So this will be our model, and now let's already add our controller. So additionally to the weather forecast controller, right click the controllers folder, we hit add, and then not a new item, we go to controller and then API, not MVC. I don't know why this is still the default, but what I want is an API controller. We got a bunch of options here, but I really love the empty one. It's, in my opinion, the best way to learn. And also for future implementations, you have full control in your controller. So API controller empty it is. We hit add. We give this thing a name like video game controller, and there we are. There's already a difference here to the weather forecast controller, because as you can see here regarding the route, I don't know why this is still the case, but here we only have the controller term. But in the video game controller, by default, we got API first, then slash, and then the controller term. Works for me, and I think it's a good way to do it like that, because then we really see, okay, this is the API. What is the same is the controller base class, because when we hover over this thing, we see a base class for an MVC controller without view support. Now this might be a little bit confusing. Patrick, you told us an API controller, not an MVC controller. Yes, this is true. Now, what's the difference? If you build an MVC application, you also get view support. Now, this might be a bit confusing, and you don't really have to know this to be able to implement your API controller. In the end, this just means it is a controller, but regarding the view, we will use something different. When you build an MVC application, you can already use this controller for your view, so meaning for your front end, if you like, but not in our case. We only want the backend stuff, only the web API. And when we go here, try to go here and have a look at the implementation. Finally, there we are. We see we have an HTTP context, we have HTTP request, the response, and so on. Lots of great stuff. Again, I don't want to go really deep here. For that, we got stuff like the .NET Web Academy. Again, big discount now to celebrate the release of .NET 9 and the upcoming Black Friday week. So maybe you want to check out the video description for the link. All right, lots and lots of great stuff. We focus on our implementation here. I think this is much easier. So let's build our get method. But before we can do that, we need, well, video games, right? So I've got something prepared here. So here we have our static list of video games. Now, why static? Well, we need to know the states in this web API. If we would leave the static keyword and we have just a private list of video games, and then for instance we add a video game, then as soon as we try to get all the video games, read all of them, we still only get these 3 and not the 4th one that we've added because the state is lost. This is a web API, it is stateless. That's why we add a database later on. Just make sure to use, for this example, a static private list here. And again, in a real world application, of course, you probably won't store a list of video games here directly in the controller. I will use a fat controller. We've got some discussions on my channel regarding exactly this issue here. Should you use the logic that we're going to implement in this video in your controller, or should you use separate services, repositories, stuff like that? But for now, just make sure to add your list here and make it static, and then everything should work just fine. But now, again, let's build our get method finally. So here, very first thing that you might want to add again is the HTTP request method. I will explain them on the fly when we implement them. But here now, again, a get method, we only want to read data. It is a query in the end. So HTTP get it is. And here now we say public, and we want to return an action result. Now, what the hell is an action result? Patrick, I watched the weather forecast, so here we don't have an action result. Yes, it's true. It also works that way, but again, I want to use better practices here, and what I want to do is using an action result, because with an action result we can also return a status code. To go a bit deeper here and tell you a bit more details, the status code is something that is implicitly used in that controller, meaning that even if we only define in our signature here that we want to return a list or an I enumerable of weather forecast, and we only return this list, we still get a status code 200, which means that everything went fine. This is status code 200 okay. All right. Again, when we check out our beautiful new Scalar here, we see here in our response, we get a 200 OK, right? An array of objects. But the important thing is we have this status code here, although when we go back to Visual Studio, we are not really defining that we return an action result. Now let's just continue first with the method and add the actual object that we want to return. So action results, then a list of video game. Let's call this get video games, and then here we simply return. Now we could just do it like that, right? Return the video games, and by default we would get status code 200. Or what we can also do is write OK. And when we now have a deeper look at the OK function, here we see creates an OK object result object that produces a status code status 200 OK response. When we have a little deeper look at the OK object results, then we see this inherits from object result, and this thing then is an action result that on execution will write an object to the response using mechanisms provided by the host. So this is how everything comes together, and this is why I like to use the action result here as a return type. Anyways, let's test this now by restarting our application. We go back to Scalar now. Let's refresh manually, and now we see the video game here and also the video game model down here. Isn't that nice? So Scalar knows this already, and we also see that we have our get method here. We see that we expect an array of objects with 200 OK, and this is our example result. So let's just test the request. We hit send, and we get our beautiful games: Spider-Man 2 for the PS5, Legend of Zelda Breath of the Wild, and Cyberpunk 2077. All right, I know, lots of boilerplate, lots of foundational stuff, but now we can continue with the other implementations. Real quick, if you want to level up your skills with .NET and Blazor, now is the time to join the .NET Web Academy. You get over 40 hours of pure learning content. We cover things like clean architecture and CQRS. We dive really deep into all the new render modes of Blazor. You will learn how to publish your web applications with the help of GitHub Actions and Azure, and you get access to our community and the brand new Discord server with live collabs. So make sure to use the link in the video description below for a huge discount. I'm really looking forward to seeing you inside the Academy. So the next step would be not already creating a video game. Usually you would also want to implement a function where you get a single entity, so a single video game in our example. So let's just do exactly that. Now let me start with the function signature first. Again, we are returning an action result. This time it's a single video game, and we can call this get video game by ID, for instance. So IntelliCode almost correct. So in here we now say var game is video games, and then first or default. And yes, this is exactly what I want. Maybe instead of X, we could say G for game, but this is totally up to you. And what you see here is a so-called lambda expression. As you can see here, it needs a predicate. This is the same stuff in the end. So what we want to get here is actually an object from our video game list where the ID is the same as the provided ID here, as this parameter, as this argument here. Now, if we don't find one, the result would be null. So if game then is null, we can return something else. In this case, not okay. I think you know this. Maybe we want to return a 404 not found. And for that, we also have a function. And that's our not found function here. As you can see, this returns a status code's status 404 not found response. But if we have a game, then exactly we simply return OK game. Now the attribute. We also add HTTP get, but we also need a route, because in the route we have to provide the ID that we want to get. We have two options now. We can either use it similarly to the attributes of this controller. There is this route attribute, specifies an attribute route on the controller. And here now we could add something like that, quotation marks. And then since we only need a parameter here, we can say, give me the ID. And these two, this thing here and this thing here, these have to match, because now the controller knows, okay, this argument here is provided by this route. And there's also another way we can combine these two attributes. And for that, we just grab this thing here, move it here, and in the end then this is exactly the same. So now we have the HTTP get attribute and we add a route, which is just the ID. So let's save that and again have a look in Scalar. Seems to be a bit buggy still. We have to refresh this manually. I hope this will be fixed soon. Again, we have our models, and now you see a new endpoint, API video game, and then the ID in curly braces. This means this is a parameter, an argument that we have to provide. You also see this here, path parameter, signed 32-bit integer, commonly used integer type. All right. Now, when we test this, we see here path variables, ID. So now, for instance, when I hit or choose ID 4, we hit send, then we get the 404 not found. So this is absolutely correct. But what if I now just use ID 1, I hit send, then I get Spider-Man. So this already works. Great. So now it's time to create a video game. All right, so now the actual HTTP request method is post. Post is the method that you might want to use when you want to create something. All right, so a brand new object. You don't want to update something, you don't want to delete something, we want to add something, and typically for that you would use the post HTTP request method. Now regarding the function, we start pretty similarly with an action result, and we return a video game, the newly created video game, let's say. Call this add video game, and then video game new game. All right. And let me make some space here. So now we first check if new game is null, then we can return something else. We got 200 okay. So far we got 404 not found, and IntelliCode is totally right here. We can also return a bad request, because this means something is not correct here. In our request, we need a video game object. All right, now, since we don't use a database so far, we only store our stuff inside our web application in memory, in essence. We have to also change the ID manually. So how would we do that? Let's just say for our ID, we grab all our video games and now use this function here, max, where from the ID of all the games in our video game list, and we just add 1. As you can see here, this function invokes a transform function on each element of a sequence and returns the maximum integer value. All right, so from all our video games, the maximum ID so far should be 3. We increase it by 1, so the next ID should be 4. All right, then we simply add the new video game to our list. All right, and now we could just return okay with the video game, but typically what you would return is a bit different status code. In this case, this is created at action. As you can see, this is status code 201 created. So we created something new and we provide something, an action name and the new object that was created. So here now we give this thing or use the name of our get video game by ID function, because now we want to provide the new object with the new ID. And for that, actually, we do the following. So new and then ID is new game ID, and then our actual object, which is the new game, like that. All right, so this is our post function. Let's test this real quick. Back to Scalar, and now we see we have this new post function here, and it also says for the body, we need something with an ID, a title, a platform, developer, and publisher. Now, ID, this is not totally correct. We don't really need it. Of course, we're using our video game model, so this is why Scalar says this thing has an ID, so please provide also an ID. But in the end, we can choose what we're doing with our body. Now, if you're used to Swagger, you see, this is a bit sad. We don't have an example body here, so we really have to type it in manually. If you know more, please tell me that in the comments. Maybe there's an option in Scalar to automatically create an example body. So now, as you can see, I've got only the title, platform, developer, and publisher, and the ID then will be set by us in our function. And by the way, if you want to dive deeper into the actual objects that you want to send to such a request, such an endpoint, these would be something like DTOs, data transfer objects. Check out the info card. Talked about that also in another video. But here now, let's just do that. We use this object, we hit send. And as you can see, we get the 201 created back from our web API and also the new ID 4. And to double check, let's just get all the games again. We test this request and we see 1, 2, 3, 4 with Halo Infinite. And of course, when we now try to get only Halo Infinite, then we provide ID 4 here, we hit send, and there it is. Perfect. So creating also works. Next step is updating. For updating, we have 2 options regarding best practices for our HTTP request method. So as you can see here in the suggestions, we got patch, which says identifies an action that supports the HTTP patch method. Not really helpful, right? And also put supports the HTTP put method. Now, what's the difference? With put, you usually want to update the complete object, all right? And this is what we're going to use here, although maybe we won't update all the properties in the end, but still, when you want to provide an endpoint that is able to update the complete object, except the ID maybe, then you would use put. And patch, maybe as the name already implies, says that you only want to patch an object, so maybe just change one single property. In the end, you have to decide how you implement your logic and then decide which HTTP request method you want to use. But for this example, I would like to use put. And what we also typically do here in such a method is we also want to provide an ID, similar to the getById method, because we first have to grab the object from the database maybe later with the help of the given ID and then match this with the object that we provided. So here now we have an ID, which will be a parameter, and then also the updated video game. So first, again, similar to the getById method, this is our attribute together combined with the route. And then regarding the function, we say public action results. In this case, we don't return anything. So what we can also do is just use the interface, the I action result, and call this update video game. Now again with the ID and then with the game, but this time it's an updated video game. And again, let me get some space here. All right. Now I'm repeating myself, but similar to that function, we can actually grab this code. And of course, we could refactor this so we don't have duplicate code here, but still this works. We check if the video game actually exists. If not, we either return a not found or maybe also a bad request because this thing does not exist. And then pretty simple, we manually update the properties. So here I want to update everything. So a part of the ID. So let's say exactly the game title is the updated game, not updates game, updated game title. Then we got game platform is the updated game platform. Then we have the developer, which is the updated game developer. And the last thing, of course, the publisher, which is the updated game publisher. And in the end, typically you return no content. And with that, then we know everything worked. So let's test that. In Scalar, we have a brand new function. As you can see here, it looks like the get function, right? With the same route, but this is important. The HTTP request method is put. So let's test this request. As you can see, we have this ID now. And I actually want to change Cyberpunk. Now to make our lives easier for this test, let's just get the game first. So here now, ID 3, hit send. Now I can just copy this thing and now go to put, test the request. And now here again, nope, there it is. ID is 3. And regarding the body, let's just add everything. And here I just changed the name to Phantom Liberty. We can again remove the ID actually, except you want to double check and say, okay, I got the ID, this specific ID as a parameter. And then also I want to check if the provided object also has the same ID. It's another way, an additional way to make sure that everything is correct in this request, but it's not really necessary. And as you can see, we got 204 no content. So we found the object. This is nice, right? And we changed something. So let's check that by, for instance, receiving all the games again. We hit send and there it is. This is our change. Cyberpunk 2077, Phantom Liberty. Great. So this is updating the object. This worked. And the last one is deleting. Now, regarding deleting, the request method is pretty simple. It is just called delete. And again, we also need a route because we have to provide the ID of the object that we want to delete. All right. And now again, we say I action result because we again return no content. We call this delete video game with the ID like that. And again, we check if this thing actually exists. All right. And if it does, we say video games remove game and then return no content. Simple as that. Let's test this real quick. There is our delete function. Again, let's see what video games we got so far. We hit send 1, 2, and 3 because we restarted the application. So the state is not stored, of course. Halo is not here. We don't see the change. Again, we restarted the application, so this is why the state has changed. But of course, we can still add a game or just delete Cyberpunk, for instance, for this example. So we test this request. Again, when we, for instance, hit 4 now, we get not found. But now what about 3? We hit send 204, no content. And now when we get all the games, we see we only got Spider-Man 2 and The Legend of Zelda Breath of the Wild. All right, now the next step is to add persistence to our application. This means we store everything in a database, and for that, we're going to use a SqlServer Express database, which is available for free, and Entity Framework. So how would we do that? Well, the first step is to create a so-called DbContext or a database context. Now for that, the easiest way is to add a new folder here. Let's call this thing data, for instance. And then we add a new item and we call this, for instance, VideoGameDbContext, because in the end, it's really just a video game database. Now here we can use, of course, the primary constructor. So here now the VideoGameDbContext needs a parameter, and this is the DbContext options of the VideoGameDbContext. We call this thing options, and then we want to inherit from DbContext and we want to use the base constructor here, so DbContext, and we give this thing then also the options. Now we see big red lines because Visual Studio has no idea what we actually want to do here, but it can help us. So we click, for instance, on the DbContext and then hit Control and period. And here now we already see the suggestion, install package Microsoft Entity Framework Core. We go there and go ahead, find and install the latest version. And when this is done, we have to do this one more time to add the reference. So using Microsoft Entity Framework Core, and then we are done with this thing. We have our DbContext already. But with this context by itself, nothing really is happening. We have to add a database set, and this database set then will result in a table in our database. So how would we do that? Well, we just add a property. For instance, with prop, hitting tab, we can say now give me a db set of the type video game. So this means now we store the entity video game in our database, and we also have this, we have to give this thing a name, of course, and usually you just pluralize the name of your entity, and this then would be the video games. So in the end, you get a table that is called video games. Now there's one disadvantage here. As you can see, we get the warning that this is a non-nullable property, could be null. So what's a solution for that? Well, now a better practice to do that is to initialize this thing already with a set also of the type video game. So why this approach? Well, we have no nullability warning. It's a clear syntax actually, and again, also considered best practice. All right, now, so far, our DbContext is done. And now we have to slowly move over to the actual database. So the first thing we need is a connection string. We have to tell our application where it finds the database. For that, usually we go to the appsettings.json. We can also store this as an environment variable, for instance. But when you use a connection string here, you can also just publish your application to Azure, use the same name of the connection string also in Azure, and then you don't have to change anything. Meaning when you develop locally, it will work because you're using the connection string of the appsettings.json file. But then when you configure Azure, your application in Azure, set the same name of a connection string, then your deployed application will use this connection string instead. Beautiful stuff in my opinion. So here we can add connection strings. It is already suggested for us. And typically you would just name this now default connection. You could also call this VideoGameDB connection, of course. And this thing now could be a bit complicated, so I have to look this up every single time. I cannot remember this. So what we got here is first the server, and in our case we want to install or use the SqlServer Express. We're going to install it in a minute. Bear with me here, but for now it's just called then server is localhost. In my case, we'll install this locally, and then SQL Express, like that. Then we give the database a name, maybe just VideoGameDB. All right. Then we set the trusted connection to true. And one more thing, we have to set trust server certificate also to true. All right, so this is now our connection string. And now we also have to register our DbContext so that our application really knows of the DbContext and knows how to use this thing actually. So for that now, what we can do is we say builder services. If you're already familiar with dependency injection, for instance, then you know that you have to register your services here in the Program.cs, and we do exactly the same stuff now with our DbContext. So it says add DbContext, and we want to use the VideoGameDbContext. All right, and then we can also again set some options here. For instance, we want to say that we want to use the SqlServer provider. So we say options, and then options use SqlServer. All right, we don't know this function yet, but here this function wants the connection string. So we get this thing with builder configuration. So this is now our appsettings.json file in essence. And then here we say get connection string and then default connection. So with get connection string, you can see it here. this gets the specified connection string from the specified configuration, and it's shorthand for get section and then connection strings. So it's kind of a convention. All right, now what's with this function here? When we press Control and period, we have no suggestion. Well, we need the SQL Server provider for Entity Framework. So let's install this thing as a NuGet package. So here now, right click our project, manage NuGet packages. And then here we say, let's just enter SQL Server, for instance, and we already hopefully get the one. That's the one. You already saw it, but now we have refreshed this thing. So anyways, it's Microsoft Entity Framework Core SQL Server. And you see the detail here says Microsoft SQL Server Database Provider for Entity Framework Core. So let's install that thing. We hit I accept, of course. And when we now go back to our Program.cs and try this one more time with Control and period, now you see we can add the reference using Microsoft Entity Framework Core. And this works. No error anymore, except this thing here, where I, of course, forgot to add another parenthesis. All right, but now we have no error anymore. Great. So we got our DbContext, we got the connection string, we registered the DbContext together with the SQL Server provider, or using the SQL Server provider. So now let's install SQL Server. The easiest way to do so is simply Google for download SQL Server or download SQL Server Express. We then probably use the first hit here, and then when you scroll a bit further down, you see the Express version, and then you can just download this thing. And then what I can really recommend to do is also download and install SQL Server Management Studio here. You will also get the suggestion when you install SQL Server, also the Express version, because this is, in my opinion, a great tool to, well, maintain and work with the database. So here now, you should see the link, download SQL Server Management Studio. Just hit it, download it, and please install the thing and then come back to the video. Because here now in Visual Studio, the next step really is the migration. Now, what is that? Well, in essence, the great thing with Code First Migration is that we can just write our code with C#, and Code First Migrations is then creating all the database related stuff. So we actually do not have to create our database and the tables, insert data, and so on manually. With SQL scripts, we can just write our C# code and then add migrations, apply them, update the database, and then everything is done for us. So let's do that now. For that, we need another NuGet package. So right click again, our project file, and here what I want is only one thing. I'm looking for tools, and then I need the Microsoft Entity Framework Core tools. Entity Framework Core tools for the NuGet Package Manager console in Visual Studio. And here now you can see what this provides. We have add migration, bundle migration, drop database, and so on. So lots and lots of stuff we can do when we got the tools installed. There's also another option to use the CLI, the .NET EF tools instead. I used them before, but now I think this is even more convenient. So just use the Microsoft Entity Framework Core tools package here and you're good to go. So with that now, we can simply go to the Package Manager console, make sure that this is really your default project. If you have more projects, right, so you need to select the project where you have your DbContext. And then when I get some space here, we can do the following. I just write add-migration, hit tab, and then we give this thing, the migration, a name, for instance, initial, because this is really the first one. And this thing now will try to build our application and then create a migration file for us. And it should also open this file. And as you can see, now we have two methods, an up method and a down method. And as you can see in the up method, it will create a table for us with the name Video Games. Remember, we got the context here with the DB set Video Games. So this is really the name that we chose earlier. Now let's go back to the migration file, and here you can see it will create all the columns that we have as properties in our model. Again, here VideoGameCS, we got ID, title, and so on. And here now we have our columns. And the great thing also is that now this thing is an identity, meaning that whenever we insert a new entity, the ID is incremented for us automatically, right? So this is really nice. And also we got the right types, which is pretty simple in this example. Again, we got the title, platform, developer, publisher. And again, I know we could create another entity for instance, the developer and the publisher, also for the platform, of course, and then add a relationship, but this is something for another video. All right, then one more thing also great is that automatically .NET knows that we want to use the ID as our primary key. And then in the down method, this just means when we want to roll back the migration, we can also do that. Then it's just dropping the table. Simple as that. I would say we run this thing with update database. Don't get confused here. Although we don't have a database yet, we still use the command update database. It will also create the database for us, as you can see here. So now it is doing its magic. You can scroll further up and we see execute db command. For instance, create database VideoGameDB. This is the name from our connection string. And then it will also create now here the system table, actually EF migrations history for entity framework. So here it is stored which migrations have been applied. So this is not interesting for us for now, but somewhere we should also see the create table command for our actual table. There it is, create table video games with all the column. Great. So now let's have a look in SqlServer Management Studio, I'd say. So let's just open it. There it is. All right, and now we only open the databases. Please ignore the blazing block and time tracker database. These are from the .NET Web Academy. Link in the video description. But here now the video game DB with the tables. And here we've got our video game table. You can see the columns. You can see the keys. Perfect. And with select or edit top 200 rows, we see there's actually nothing to see here, right? We've got our ID, title, platform, come on, and the rest of the columns. But we need some data. So the next step is we could either enter games manually here, or we seed some data. We can also do that. And then with the help again of the code first migrations, we can just automatically insert data into the database. So let's do that next. So for that, we go back to our DbContext, and there is the method called onModelCreating that we can override and then add our data in there. So for instance, we write protected override, and then we should get the suggestion if we do it here inside the class, of course. And then here on model creating it is. We have our base on model creating with the model builder. And since I'm a lazy guy, I will just copy the games also to save you time, really. And then we just do the following, hopefully with a correct format. Yeah, this looks better. So as you can see, we can write model builder. Then for the entity video game, we want to call the function has data. See it here, adds seed data to this entity type. It is used to generate data motion migrations. This just means that when we now add another migration and apply this, update the database, then these three entries will be inserted for us. We've got Spider-Man 2 again, similar to the first video, right? Legend of Zelda and Cyberpunk 2077. So with that, again, we go to the package manager console and then say add migration, and this time, for instance, just seeding. And we get our new migration file. And as you can see here in the up method, it says migration builder insert data into the video games table. These are the columns, and this is the complete data. And in case of a rollback, we would just delete the entries with the IDs 1, 2, and 3. Simple as that. And now with update database, we can really insert our data. So we should see the insert statements. Yep. Again, migrations history, but there it is, insert into video games and so on. And when we now go again to the SqlServer Management Studio, I right click inside the table, execute SQL, and there are our games. Isn't that nice? I did this countless times, but every single time I love that this works that way. It's just awesome. All right, so now we got everything covered regarding the data, but now we need the CRUD operations, right? So how would we do that? Well, we did everything stateless, let's say, although we have a static list here, but when the app crashes, when it's stopped, then we lose all our data that we changed, right? We have the 3 games here, but when we add new ones, update ones, then the data is gone. And this, of course, should change when we add a database now. So the first thing I would like to do is remove this static private list of video games. Of course, we get a bunch of errors now. And then we just move from one method to the other. So let me first comment these out. All right. And before we can change this thing, we have to make use of dependency injection. We want to inject the data context now so that we can access our database table, the video games. So how could you do that? Well, we can just use a constructor typically and then inject the context in there, or since C#12, we can also use primary constructors. I leave this up to you, but since it is newer, let's say, to use primary constructors, let's do it the following way. We have a private read-only VideoGameDbContext. All right. So let's add the type here. We call this now context, and we say that this is the context. Looks strange maybe, but again, with control and period, we can either choose the generate constructor suggestion here, or we just say, usually we should get another suggestion. Well, of course, when recording the video, I don't see the suggestion here, but for instance, we can do the following, right? In this case, you would just remove the context here. And this is, let's say, the old way without the primary constructor. But instead of this way, we can now also do the following and then just say VideoGameDbContext context. And here now we say this is the context, and remove this constructor here. So now you saw both ways. Again, I leave it up to you. Honestly, I think the old way is a bit more clean. It's really cleaner, I think. But anyways, if you want to use primary constructors, this is the way to go. And now regarding the get function, so really get all the video games, what we change is we make them all functions here asynchronous with async, and then returning a task of an action result with a list of video game. And then here, instead of just the video games that we had before, we now say await and then context, and then we can enter our table. So video games, and here simply to list async. All right. So this is how you get all the games. Now, a really quick recap. With .NET 9 and web APIs, we don't have Swagger and Swagger UI anymore, but there's a quick fix. You can either add Swagger back or you just use Scalar. It seems this is the new way to do API documentation or testing APIs. At least the community likes Scalar very much. And for that, you need the package Scalar ASP.NET Core, and then you only have to add one more thing, and this is this line here, map Scalar API reference. And of course, this also needs add OpenAPI and map OpenAPI. So add and map OpenAPI will provide the configuration file of your API automatically, and Scalar just uses this thing. So let's run this, refresh, and there it is. Now we have only one method here. We can test the request, we hit send, and we get the games from our database. Isn't that nice? All right, so this works already. Now let's go back to Visual Studio, and then we add the other methods or implement them. So here in our controller, let's uncomment the getById method. And here now we only have to change this single line. So instead of the old video games list, we say await. Of course, we have to also add the signature, context, video games. And then we can use find async. And then here we only provide the ID like that. And here now we also add task for the return type like that. And we're done. So again, we access the context, our video games table, and then we try to find the one with the given ID. So let's try that one more time. It seems in the current state, we have to refresh this thing manually. So here now we can test the requests, and here we see the variables, the parameters for instance, use ID 1, we get Spider-Man 2, and with ID 4, we get a 404 not found. Perfect. So this works as well. Now, next step is adding a video game. So here now, again, the signature is async task action results. If the new game is null, we return a bad request. But now we don't have to use these lines. These have to be changed. The rest can be the same. We simply say context and then video games add, and then we want to add our new game. And now this is crucial. The get methods before have been so-called queries. So we do not change anything in the database. We just want to read something. So here now, we also want to change something. We want to add something. This is then called a command, similar to maybe you know it's CQRS. We also dive really deep into CQRS together with clean architecture in the .NET Web Academy. So there then you change something in the database. And this is why we also have to call the following await context save changes async. Because the add method here says it here begins tracking the given entity. All right, so only the tracking begun, but we did not really store it in the database. But then with calling save changes async, it says saves all changes made in this context to the database. So only with this function then the data is really stored in our database. So make sure to really add this function as well. And we can of course test this. So let's refresh. We test the request, and I've got an example. This is the wrong one, the post one of course. So we test the request. For the body, I've got an example here. We hit send, and you see now we've got a new entry with ID 4, and we can even double check now in the database. So again, right click, execute SQL, and we see Halo Infinite with ID 4 now is also in the database. Isn't that great? Okay, now let's change something. So updating back to Visual Studio. Here is our update function. Uncomment everything. Again, we add our async keyword, returning a task of I, action result. Why now the interface? Well, we don't return anything here. This is why we can also use the interface. Now regarding the beginning here, let's just say we can actually use the same codes. I know it's duplicate codes. We could refactor this. I know. But let me just paste it here now for, well, convenience and time, saving time. And the great thing here now is we can actually leave everything as it is, but we made a change. It is a command. We made a change to a game in the database, so we also have to save these changes. So again, we call await context save changes async. This was quick, right? So let's test this again. Let's refresh. We have our put method now here. And with test request, let me get another game first. Do you want to update? For instance, ID 3 is Cyberpunk. Great. So now here is put, test request, ID is 3. Now regarding the body, this is the change. One more hint. Typically, maybe you don't want to use an object with ID 3. Maybe you want to use something like a data transfer object, DTOs. Check out the info card, please. Then this would be cleaner code in the end. But again, for this example, let's keep this simple, and we change just the title to Phantom Liberty. We hit send, no content, so we can double check here by receiving all the games, hit send, and we see the changes here, and also Halo Infinite is still there. And now again in the database, we refresh and we see Phantom Liberty. Great, so this worked as well. And now the last thing is to, well, delete a game. So back to Visual Studio. There it is. We uncomment. Again, let me just copy this part and do it here or paste it here. Of course, we have to add the async task again, like that. And now here it is almost the same. Again, we need the context, of course. We want to remove the game from our table. And again, what's missing? We made a change. It's a command, so we also have to save this change with await context save changes async. We test this one more time. There's our delete function now, or delete endpoint rather. We choose Halo now. We hit send. No content, but again, when we try to get all games, we see just 3. And in the database, we also refresh, and Halo is gone. All right, so now we've got our data stored in the database. But what about adding the relationships I've talked about earlier? Well, this is a crucial part of building web applications. Again, for instance, we could add separate entities for the developers, the platform, the publishers, stuff like that. Well, I've got the right video for you. Just go ahead and click on this video here you see on the screen.